All right. Hello, welcome everyone to another day of daily LeetCode live streams. I want to do a quick sort of housekeeping here, just explain some things before we move on. So doing the stream a little bit later today, I had to deal with a personal matter, but everything's okay. Everything is good, but I wanted to make sure I came and did the stream today. This stream will probably be shorter. And because of that, I'm probably just going to focus on one question, but it actually worked out pretty well for us because the question I'll be working on, I think, is very high value. And of course, I'll be adding it to my website after, so that way you all can keep your own track with it. And you can also see the chapter once that we're done with this stream. That's like one of the first things I want to mention. The second thing I want to mention is you may have seen yesterday, I put out a video on a new series that I'm calling With Vanilla. So With Vanilla, like the description implies, is a playlist where I do front-end projects using vanilla JavaScript. The first one I did is called Create a Binary to Decimal Converter using vanilla JavaScript and Cypress. So Cypress is a great end-to-end testing framework. I think that end-to-end testing is pretty important, and a lot of developers are struggling with it. So I wanted to just also incorporate that a little bit into these videos because I feel like it can give you all a little bit more value, and I'm very happy to be doing that. These won't be as consistent as my daily LeetCode videos, but since I do enjoy front end, I wanted to just throw that out there and see how the audience responded. So far, I'm pretty happy. You know, it's gained 23 views in less than 24 hours, which at this stage I'm very happy about. So that's pretty cool. You know, the channel's been growing. I'm trying to experiment with new things. We just hit 300 subscribers, so thanks to everyone for making that happen. And I'm very excited again for the future of this channel, and I'm just going to continue going on with it. And I truly hope it brings you all great value and happiness just going through all these questions with me. So with that being said, let's go ahead and get started. And the question we're going to do today is called Merge Two Sorted Lists. So it says that we are given the heads of two sorted linked lists, list 1 and list 2. Merge the two lists in a one sorted list. The list should be made by splicing together nodes of the first two lists. Return the head of the merged linked list. So you can see here we have 1, 2, 4, and we have 1, 3, 4. And I think the best way of me really showing how to do this is, of course, with a drawing. So let's go ahead and do that. I'm going to delete all this. Let me go ahead and bring this to the right and this on my left. And of course, we're going to do a drawing of this picture just like it looks on the screen here. So let's go ahead and get our circles ready. Let's do 1, 2, and 4. And then we'll have some circles down here for 1, 3, and 4. Let's of course not forget our arrows. Let's get these in here. Okay, so just drawing things out. We have a 1, we have a 2, we have a 4. We also have a 1, a 3, and a 4. Okay, sweet. Now, one thing to notice, and one very huge hint in this whole question, is the fact that both of these lists are already sorted. So if you think about something like merge sort, for example, right? There's a step in which you're looking at two different arrays, and in each array you're picking off the smaller value and then putting it into a new array of sorted values. And that's the thing that you're essentially going to be sorting and then finally merging back into a bigger, larger array. It's almost sort of the same thing here, right? We have two different lists, presumably each with their own pointers, which instead of just saying presumably, let's go ahead and actually denote that by, of course, using my famous diamonds. These diamonds represent, so this one represents this node and this one represents this node currently. I'll be moving these as we go along through the algorithm, but let's sort of think about how this works. So at each point, right, what is it that we want to do? Imagine we have a pointer that points to the beginning of each one of these. How do we know what the next one should be in either of these cases? Right? We have a pointer that points to this one and a pointer that points to this one. So it's like the lowest of these two is what the next of one of these should point to. Now, you might be asking yourself, well, these are both 1. So first of all, which one do I pick? And like, which next pointer do I set? That's always been something that's been a little bit confusing for me in the past, and it wasn't until I actually read through some discussions a couple of years back that I figured out a very important thing with linked list questions. And I'm sure there are plenty of other ways to do it, but for me it has always made sense, and I'd like to introduce the concept now. This concept is what's known as a sentinel node. So a lot of times when you think about sentinel, so if you think about like C if you think about like C strings, when I say C string, I mean like an array of strings, right? If I remember correctly, back in my C days, we know that the end of a string is denoted by the sentinel, which is this like / or \0. Now let's see if we can actually look that up. Sentinel node \0. Sentinel lymph node. Is there, let me see, C string relation with 0. So it says here, C style strings are traditionally stored with a null terminator. Do not count this null terminator and we'll give you the human length of the string. Hello is length 5. So determine where a string ends, right? So the use of the terminating null character allows the program to determine where a string ends. So in a similar fashion, what we're going to be doing is we're going to be creating a sentinel node that instead of acting as the end is going to act as a dummy beginning. And I'm going to mark this as S, and I'm also going to create, let's say, a smaller square, which would be nice to have this with like, yeah, let's make this like blue, something like this. This will be like my sentinel node here. And now if we think about it, the nice thing with this node is we can now start here, and we can always ask at any given point in our algorithm, as long as these 2 pointers are valid, which next one is the minimum one, right? So I've already given a couple of keywords here. While these 2 pointers are valid, we can always take this current node and point it to the thing that's the minimum. So let's figure that out. These 2 things are currently valid, so we ask ourselves which one's less, 1 or 1. Well, the first one, right, if we say is 1 less than this one, this will be no, right, even though they're the same. So in this case, we'll just pick this second one. So it's actually draw an arrow. And let me give this like a different color. Let's draw this arrow here. Okay, this is going to denote the first thing. So now we have this sort of node going on here. Now, as we continue along, let's say now we have like a different pointer here, right? And let's say we have, oh, I guess we can use this one. So now we're here. Now we say, okay, from here, which one's also the smallest? And now, by the way, since we've already picked this one, we should go to its next, right? We should send this one to its next now. Okay, sweet. So now we're here. Now we ask ourselves, what is less? The 1 of this one or the current node, right? The 1 or the 3? Well, we know it's going to be the 1, right? So what do we do? And actually what I'm going to do is I'm going to sort of like delete this node here and draw another arrow going this way. Now we can move our sentinel node up here, or rather our sentinel pointer up here, and move this pointer this way. Now we ask ourselves, what's less, the 2 or the 3? Right? The node that's pointed at by this one or the node that's pointed at by this one? Well, it's going to be the 2. So essentially we can leave this pointer, but I'll redraw it just to show that we made a change. We'll move our sentinel node here, we'll move this pointer here, and now we're here. Now we ask ourselves again, what's less? The node being pointed at by 4 or the node being pointed at by 3? Well, it's 3, right? So we'll delete this one, point this one this way, we'll increment this pointer, and we'll send our sentinel this way. Now what's less? You can imagine that we might have something like, is 4 less than 4? No, it's not, so just pick this next one. So really we just pick this one here, right? Now this one, I'm going to draw it up here because I'm just off the screen, but I'll put it here. I'll move the sentinel here, and now check out what happens. Now we no longer have like a valid case, right? Where we can say that both of these are valid. As soon as either one of these is invalid, we can really just say that the sentinel node should just point to this node that presumably either contains the end of another list, or even if this continues going through 4, 5, 6, 7, 8, it's just going to be a single list since this one down here is no longer valid. So we can essentially just point this one to here. We can send this one over here. This one resumes, and that's it. Now at the end, right, the only thing we have to return is the next pointer of our sentinel, which is 1. And now we're left with 1, 1, 2, 3, 4, 4. And if we look at the output here, 1, 1, 2, 3, 4, 4. Exactly that. So let's see if we can figure out a way to generate some code for this. So let's think about all the different things we've done. I'm going to start undoing things. I think it's useful for us to go through the whole process again, right? Why don't we first create we have list1 and list2. These are going to act as the pointers that these diamonds represent right here. Now what we can do is we can actually get to the sentinel, and let's see how we can create that. Now, before we even continue, let's make sure, let's see, the number of nodes in both lists is in the range of 0 through 50. Node.val, both list and list2 are sorted in non-decreasing order. Okay, so what we can actually do in the beginning is if there's going to be 0 nodes, if there's a possibility of having no nodes, can we do something like if not list1 or not list2 return list1 or list2. Right, so if either one of them are empty, if they have no nodes, which I'm guessing that's what it means, we'll just either return whichever one of them is the non-null one. That's sort of like a small edge case that we can get away from or sort of handle. But now let's think about this sentinel node. So what I'm going to do is I'm going to create a new node called sentinel. And the cool thing here is I'm just going to use this constructor up here for list node. So I can say new list node, and let's say I'll just give it a value of 0. So that's fine. Now, inside of here, we said that we want to do this while list1 and list2 are valid. So we could say while list1 and list2, what is it that we're going to do now? Okay, so we know both of these are valid. So now let's pick the next one, right? Let's see. If we need to say that if L1, so if list1 and let's see, if list1.val is less than list2.val, we're going to do something else. We'll do something else. But we know what to do here, right? If list1.val is less than list2.val, but let's handle this second case because this else is where we'll start here. In this case, what is it that I want to do? I want to say that my sentinel.next is equal to list2. List2 equals list2.next, and sentinel equals sentinel.next. Right? So let's see what we're doing here. Sentinel.next equals list2, so this goes over here. And actually what this does is it just creates a pointer, right? Then we say list2 equals list2.next, so this moves here, and then sentinel equals sentinel.next. Now let's get to the next piece. If list1.val is less than list2.val, which it is, right? We can sort of do the same thing. Here we can say sentinel.next equals list1, list1 equals list1.next, and sentinel equals sentinel.next. So let's go over that case right now. Sentinel.next equals list1. Oh, so we'll do this. Point to here, which effectively removes this node here. List1 equals list1.next, and sentinel equals sentinel.next. So now let's keep going. List1 and list2 are still valid. Okay, cool. So now we can say if list1.val, oh, wait up a second. Oh yeah, that's fine. If list1.val is less than list2.val, which is this first case right here, we can say sentinel.next equals list1. So we essentially keep this pointer. List1 equals list1.next, sentinel equals sentinel.next. If list1.val is less than list2.val, which it's not, so now we get to this next one. Sentinel.next equals list2. List2 equals list2.next. Sentinel equals sentinel.next. Again, we also remove this pointer here. If list1.val is less than this one, no. But now we get to the else here, so we say sentinel.next equals list2. So I'm just going to delete this so I can show that we're essentially drawing a new arrow here. What if they're the same? Yeah, we'll get to that in a second. You mean like in this case, right? Yeah, it's fine. We sort of already handled this in this case, even if they're the same, right? Like let's say in the beginning right here, and maybe, well, I guess here we can handle that case here. So sentinel.next equals list2. I think, let me see what part I was in right now. Okay, I was doing sentinel.next equals list2, which is here. list 2. Oh, I think I got like a little bit confused here, because I read the question before I actually got to the next piece. So let's see, we're here, we're doing this piece. We just said this one goes here. Where was I here? Had I already, once I moved this list here, I moved it here because this one was less, so I should move it here. Okay, so in this part here, yeah, this is where we are. So I think hopefully this will answer your question, Sawyer. Like, even if they're both the same, right? Let's say list1.val is less than list2.val, so that's false, right? Because they're actually the same. So instead we'll just say sentinel.next equals list2, which will just be this. We'll just set it there. We'll say sentinel list2 equals list2.next, so it goes out of bounds here. And then sentinel equals sentinel.next, so we come over here. And now at the end, when we say while list1 and list2, well, now we know that it's broken, right? Now one of them is the only valid one left. So what we can do is actually very similar to what we did up here. We can say sentinel.next equals list1 or list2, right? And then really what we need is the one thing that we forgot to do is we should sort of have, instead of creating, like right now sentinel has moved all the way over here, so I have no way to return sentinel.next. So really what I should do is almost create like perhaps a runner. So let me say let sentinel equals list node 0, and I'll say let runner equals sentinel. Now instead of sentinel, right, let runner equals sentinel. Anytime I use sentinel, we should just be able to say runner. Runner.next equals that, and then we can say return sentinel.next. So with that, let's see what we can do. Let's actually go ahead and run the code, and let's see what this gives us. 1 1 2 3 4 4. Right, exactly. Make a dummy. Exactly. Yep, you got it right. Yeah, I was explaining that in the beginning. Like, I think there's probably like other ways of doing this question, but I was explaining in the beginning of the stream, like after reading some discussions a long time ago, like years ago, I learned about this concept called a sentinel. I was sort of comparing it to like a sentinel node in C-style strings, where you have like a null terminator at the end of a C-style string to know that it's the end of a string. This is sort of like a sentinel for the beginning of a list, like a dummy node. And yeah, you hit it right on the head of the nail. So yeah, by the way, thanks for being my most recent subscriber. You got me to the 300 mark, so I really appreciate that. I really hope that these streams are offering some value to you, and it's just good to have new people around. So let's run all of our different test cases. So it looks like everything is good. Let's go ahead and submit this code. All right, so it passed. That's awesome. We can probably clean this up a little bit. Like right here, this always happens, right? So we could move that out and do this. So it should still be the same thing. Now I'm trying to think of like, there was I remember seeing like a nice sort of optimization, not optimization, but something that we can do that's pretty cool in here. So let's see. Trying to think what it was. So was it something like if list1 or as long as one of them is valid, then we just set it equal to the minimum of either of them? Was that how it was? Well, I don't think we need to necessarily like make it. The nice thing about this is it's very clear to read. Because if list1.val is less than list2.val, we do this, or I think maybe there was a nice way to condense this condition in here, but I hope that you all might think that this is very readable, and it offers us the same complexity as the one that's nicer. We can actually revisit that too, because I always forget about it, but I know I've seen it, and it's from, I think it's Lee. Oh, is Lee no longer? Is Lee's code no longer up here? Really? Wow, that's interesting. Let me see, node, merge to, iterative approach, else. Okay, let me see if we can, this is merging using recursion. Python solutions in place. Wow, that's very interesting that Lee's solution is not up there anymore. Has it been that long? Or did they just like, did they remove him or something? That's very interesting. Did he change his name? Lee, oh, LeetCode. Interesting. Most votes. Yeah, was that we wrote on line 30? Lee is the legend. The if went to the end and we just append the rest of the other list. Right, yeah, exactly. Yeah, so what this part is saying that as soon as we get to a point, right, as soon as we get to a point where either list 1 or list 2 is null, right, then this while loop breaks, and then here we just use the null coalescing operator to say, set it, essentially this is just saying set it equal to the thing that's not null. So if list 1 in this case is not null, so I'll just set it to that, which is this one, which is the one that has the remainder. Now if list 2 was the non-null one, then list 1 would be null, and list 2 would be the thing that it's set to. So it's just a fancy way of doing that. But I'm really trying to think of what they did here, and I thought it was Lee that came up with the question, but I know there was something about like using an or statement in here, and you can essentially make this like 2 lines. So while list 1 and list 2, that means both are valid. Now if only, what would happen if only one of them is valid? Like if list 1 or list 2, yeah, whatever it is, it must be like, can I actually look up Lee? That's their name, no? I'm just surprised his is not in here. Most votes, unless I'm thinking of like a different question, but iterative and recursive, because this is, right? This is exactly what happened there. First solution. I really just want to figure this out. You know what I can do too? I think I have posted about this on my Discord a while back ago. We're going to do a little bit of Discord hunting here. So let's see. From the overseer merge to, let's see, making it leaner several times, work through else factor and refactoring. How did I even do it last time? Want to see that. Okay, did I ever write the trick here? Leanest I can get it. Oh, perhaps, okay, maybe I was just thinking about it. Maybe I was just thinking about it differently. Okay. Maybe trick is the wrong word, but nullish coalescing makes it even sexier. Okay, yeah, I was thinking about something else. You know what? It was probably a different question that I was thinking of. But yeah, it looks like the way that we came up with. Wow. So that actually feels nice because this is how I solved it back in just May of this year. I had like so much code in here. And I was able to actually reduce it to what we have now. So that's actually, that's one of the few operators better in JavaScript than Python. Yeah, I love JavaScript. Like the reason people have asked me like, oh, why is it that I use JavaScript? The reason I use JavaScript is mainly because I consider myself a front-end developer. I lean front-end and I just enjoy using JavaScript, and that's really why I use it. So yeah, I think I'm just gonna keep it to this question today because like I said, I had to deal with some personal matters today and it's been sort of like a very long day, but I just wanted to make sure I got this question in, but I'm happy that we went over it. And for you, Jenkins, since you're new, I want to let you know of, there's this website that I've been creating since you just subscribed. So this website right here, it's literally just called Raphael's List. My name is Raphael. And what I did is during this whole time of me doing all these questions and all these streams, I've tried to come up with a list of top quality questions throughout our journey. because a lot of easy questions go under the rug and people don't realize how much value you can get from them. So this website, rafaelslist.com, you can keep progress of all the different questions you've done, and you'll actually see this bar increase up here. You can do like filtering by topic, you can search different questions, and I think the thing that's the best bang for your buck is the stream clip section, where if you click on like a stream clip here, it'll take you to a video, and not just the video, but the chapter in that video where I talk about that question. So I just wanted to point that out to you since you're new. Hopefully that can also bring some more value to yourself. But anyway, I think that's probably where I'll leave it for today. We'll go back tomorrow to like the same programming that we had, and we'll get right back on schedule. But again, I'm really happy with this question today. I think it's awesome, and I really hope to see you around more often, Jenkins. So with that being said, yeah, thanks so much for joining. If you're watching this in the future, thanks for watching. Subscribe to the channel if you like the video, ring the notification bell, tell your friends and family, and we'll have a big LeetCode party. So thanks again, everyone, especially Jenkins, and I will see you all again tomorrow at 5 p.m. Eastern for our next daily LeetCode live stream. Take it easy, everyone.